coordinators of the college and every participants who are present here due to the, even if there is a pandemic situation, but still I could see this number is quite huge. It is 70 around. I'm so happy that, but of course I'm very sorry I'm late. So let us start our talk by giving a big thanks to all the attendees, and I am just going to share my this PPT, and whether it is visible or not, let me know, and then we'll move.
I will make you presenter. Just a minute.
Yeah, please make me.
Yes, ma'am. Now you
Yeah,
can.
yeah. So I can share right now. Yes. Is it visible now?
Yes, ma'am.
Okay. So this vision I have kept here the title as Novel Protection Schemes for Smart Grid. So before moving to the topic, so I just want to share a few of my thought process on smart grid. Mostly I think this introduction part will be covered by many more experts, but still I want to draw your attention that why this smart grid reason or vision is important for all of us. That I just want to draw your attention. So you know that you today is like, you know, today mostly if we'll talk about the global warming scenario and carbon dioxide emission process. So in fact, if you are interested, if any students have joined, they can also write up the points and they can interact with me, and I'll be very happy for that, okay, to answer your queries. And you can also stop in between where you could not get my points if I'm not audible to you properly. So you can always, stop me. There is no problem at all. So this the smart grid word itself may put a lot of question to you, that what is the meaning of this smart grid first, right? Isn't it? Many of you will understand, will ask yourself, what is the meaning of smart grid first? And then you will just enter inside its infrastructure, its architecture, then its definition, then its operational behavior, performance analysis, so and so, and challenges. So there are so many aspects, but of course initially we should know what is smart grid. So this grid, if you're adding one more term, smart, so that makes a very huge thought process and huge era that is known as smart grid. So smart grid is a, I mean, unspoken word, and it is it is understood one word which is within everybody's mind right now, and it will be understood in a better way if I'll put in other 2-3 points in front of you, and which will help you to conceive what is smart grid. Okay, so now, as I said from the beginning, that the global warming is an important task. Even though we are in pandemic situation, still our global warming aspects, I mean, has not been reduced. And See, and second, the carbon dioxide emission process and the carbon depletion, the exhaust of this carbon uh, within our global belt, they are all in very crisis period. At the same time, rather the population is increasing exponentially in India, and the electricity demand is also increasing exponentially. So how to mitigate, how to match these 2 points together, that is now the critical point. You can say that the changeover period right now in this is, 2021 century. This 21st century is a very changing scenario. Whatever you can take in any front, I'm just talking in front of the electricity or energy scenario, but you can talk any sort of scenario. So this 21st century is one of the changeover period for all of us. So this it is already this as I said, this 3-4 points that why we are so much worried for this smart grid word. And next thought process which comes to my mind quickly, that this that your this transportation sector, which is now it is going to be hugely, the Tata company has already declared that very soon by 2025 they are going to launch the electric vehicles in a very cheaper rate, as the petrol and diesels they are going to be adjusted, and they are also creating a lot of pollution. 20% pollutions we are getting from this carbon dioxide footprint from this transportation sector. So therefore, this by 2025 we have to be ready with some sort of arrangement, like normally we fill our vehicles by petrol and diesel. So we have different petrol diesel stations, you know. So similarly, we should have some electric vehicle charging stations in every like 2-3 kilometers distance or 4 kilometer distance. So we have to bring that infrastructure within the existing electric network. Okay, and as I said, that our demand is increasing exponentially. At the same time, the carbon is depletion has been started, and it is going to be exhausted by 2030. It will be at the end point, and almost at this 21st century, we are at the peak of our requirement. The peak of this coal demand. So slowly we are going to come down the valley point, and we'll reach to our last exhaust point by mostly the target estimation is by 2030. But however, at the same time, our requirement is not less. Our requirement, our every fund we are educated, and we are now our manpower, our industrialization process, our demand, everything is increasing exponentially. So therefore, to meet all these requirements, and so this renewables are the best ultimate source. Like in India, if we'll talk, like solar is the topmost renewable source of energy, and the second is wind, and third, of course, we have other sources of energy like biomass, and we have fuel cell, and other like tidal and thermal, geothermal sources of renewable energy. And of course, we have small hydropower plants, which are also the best renewable sources of energy in India. So to accommodate all sort of things like renewable sources, and you have electric vehicles, and top of it, which the major contribution now it is coming up, the storage devices. Let me share with all of you recently that many top tier countries in the world level, like UK, US, Canada, then Europe, every continent, like in Asia, the India is the top leading country. So they have tired of like how to develop a best storage environment, right? So I repeat again, the best storage environment. So the three things I put in front of you in a more or less in a broader picture, Renewables, we have to be dependent completely very soon. And the storage devices, we are going to be dependent. And the third wheel is your electric vehicles. So these are our driving forces which forces us, to move towards a grid, the grid which will be very flexible in nature and which will be very, adaptive in nature, which will be very accommodative in nature, and which will be very self-healing in nature, and which will be very cooperative in nature, and that is the definition of smart grid. And of course, to accommodate, to run these wheels, the fourth wheel we have to add, that is the communication, computer, supercomputing facility, advanced sensing devices, advanced sensor infrastructure. So altogether, the four wheels, if we'll combine, that creates the your automated grid, automated intelligent grid, and that is known as smart grid. The smart grid has all sort of benefits in comparison to the conventional grids. So with this, I hope that some definition I can just able to deliver to all of you. What is this smart grid? The smart grid is nothing. It is an intelligent grid, which is a combination of ICT. ICT means information communication technology. If this ICT, advanced information communication technology, will be added to our renewables, storage, electric vehicles and the existing grid with a smart adaptive control layers, then of course the developed, the modified, the new version of the grid is called as smart grid, and which will help you to provide a very, yes, of course you have to emphasize on these four words, very, efficient, hmm, very efficient and very, sustainable and very stable way of power supply. So this efficient and sustainable words, and of course one more word you have to add, reliable. This reliable, efficient and sustainable way of power supply is quite possible with help of this smart grid to the consumers. So this sustainable word is important for all of us. Sustainable means which should sustain up to 100 years, 200 years, 300 years, 1000 years. We don't know how much we have to move ahead. But if the model is not sustainable, so we don't think that that is a quite possible good solution. Okay. So therefore, so with this, I can just tell you that this particular this smart grid is quite challenging, and there are a lot many motivation I have put in front of you, few of them, and also I'll not mind again to put one more motivation in front of you, that why this smart grid is our thrust area. And this is not like, the luxury thing. It is actually our essential and requirement and very most desirable equipment and desirable area where everybody has to think about it. So this India has a capacity of more than now 400 gigawatt demand, okay, generation and demand. So more or less the peak demand is reaching to 176 by April 20. It has been changed now, and out of it, this installed capacity 370 gigawatt. This renewable is reaching around 87 gigawatt. So this renewable contribution in India is increasing drastically, and we are also progressing in it to a great extent. But unfortunately, see, actually, our requirement is too high. It is predicted that by 2030, our our government is planning to integrate around 400, more than 400 gigawatt of renewables, and which is more or less equal to our installed capacity of our country. So this figure, how to fulfill it, that is a major question for all of us. So because we don't have any, let me tell you, In India, we have lot of scope for solar as well as lot of scope for wind as well. But the only thing is you have to, I mean, everybody has to develop good skilled technology and good skilled person. We are lacking of the trained person who are very much trained with this renewable sector and renewable technology and how to install, how to penetrate perfectly to the existing grid. So that we have to work out on it. So this one more motivation, like there was a very huge disturbance in India by 2012. The large blackout was there in India. One transmission line, 400 kV double circuit line, it was 400 kV line was connecting from Bina to Gwalior, and I mean the western to northern side. We have 5 grids. We have 5 national grids. We have southern grid, we have eastern grid, northeastern grid, western grid, and north grid. So we have 5 grids. All grids are now well connected. Now that time what happened, that in the northern side some customers, they consumers, they have drawn the overpower. The power has been drawn more than the specified power. So due to that, there was a load encroachment problem in that line 400 kV line, which was joining from Bina to Gwalior. So what happened in that process, and due to the overloading of that line, one of the distance relay protection device was maloperated and that line was tripped. And so in this process, when that line was tripped, so what happened? The next line will be overloaded, and further the next line, when it is overloaded, it will be tripped, and next line will be overloaded. So further, this is known as the cascading failure of the power infrastructure. Okay, so you cannot load a line or some infrastructure above its specified value. Okay, so then the respective protective device will operate and it will trip the circuit breaker and the line will be out of order. So your service will be disrupted and it will be interrupted. So therefore, due to this, as a whole, the northern side, you can see my picture in the PPT, that northern side, whole northern grid and northeast grid to some extent, Odisha, West Bengal, Arunachal Pradesh and Himachal Pradesh, every person under, it was under blackout condition. So what is this blackout? The blackout means it was totally the power supply was the generators are shut down and there was no supply to the load centers. The load centers were disconnected from the sources. So this blackout condition had happened due to a small maloperation of a distance relay, one protective device, and it has taken a lot of billion of rupees lost. Our economic condition was also down, and many critical loads like hospitals, airport, then you have some data centers, some essential industrial builds, they have survived due to their backup supply. And in fact, the Delhi NCR and Delhi Metro Airport, they have survived because it has been detached from the main circuit and main network, and they have survived due to their backup supply. Okay, so if my question comes, if we could have sensed or forecasted or predicted such kind of disturbance beforehand, then it may not propagated and we may not get such a huge loss to our country. So even though this sort of huge disturbances are not very frequent, but you cannot even deny that it may also happen anytime. But when it will come, definitely we may lose lives and our money and economic will be down. So therefore, the smart grid will be a good solution to overcome such kind of larger disturbances, as well as for the overcoming the smaller disturbances, and to also accommodate the upcoming renewables trend and requirement to fulfill the demand of the customers. And of course, the electric vehicle is our ultimate goal now. And the last not the least, the storage is very very essential, which was missing in your conventional grid. So there are so many ways out, I just put in front of you few of them, and in a very, I touched the salient points. I have not gone in detail of it. So this, even then, we have lot many advantages from this smart grid we are getting, but at the same time, we do not, you should not forget what are the challenges which are standing in front of you. You cannot avoid it, isn't it? You will just, you don't think that, suppose you have something, some gadgets in your house or home. It has advantages, it has also disadvantages. Just like, for example, you take the smartphone, a smart inverter based AC, smart TV, smart refrigerator. All are smart devices inside your home. But every time how much we are exposed to the electromagnetic waves, our body, our mind, our brain, our total surrounding, we are surrounded by the waves, which are very hazardous for health. But at the same time, we have also some disadvantages. And the scientists, they are trying to also bring down such interference of those smart devices. Similarly, though we are actually planning for a smart grid, but there are lot many disadvantages. I mean, I cannot say, I never say disadvantages, I say challenges. The first and foremost challenge is the protection. When you are going to connect this renewables, electric vehicles, storage to the existing platform, existing grid, so definitely you will do one thing, that you have to very conscious, and you have to be very sincere what kind of challenges you are going to see.
Hello, ma'am. Your mic is muted.
Yes. So that means what I am trying to say, that we cannot enjoy only the advantages, and also we have to be very careful for the challenges which are present in front of us, right? So the let me list out those challenges. The first one is, as I said, the protection issues of the smart grid area, smart grid network. And of course, everybody, maybe some faculties, students who are present in this forum today, some of you were working in the domain of power electronics, right? If you're working in the front of power electronics, then the smart grid has the renewable integration, and in the renewable sources we have the converters, we have inverters, right? So that those converter inverter topologies should be best suited, best technology for this smart grid. That is one of the biggest, largest challenging area right now. And the second one, the person, experts, researchers who are working in the control domain, they are also responsible how to develop good control strategy for those converters, inverters, for smooth operation of the renewable sources, as well as the storage devices, as well as the grid itself. Grid voltage frequency should be maintained properly, load sharing should be done properly, and all sort of, there are so many other requirements. The controllers, without controller, the smart grid has no meaning. And not that too, only controller, adaptive controller, The adaptive controller means, why it is adaptive, because these renewable sources which are present in smart grid, they are very intermittent. Intermittent means they are very fluctuating in nature, very unstable in nature. For solar, let us take, for example, if it is a rainy day, foggy day, so the solar irradiance is something else. If it is a very sunny day, it's a not sunny day, rainy day, so the solar irradiance will be something else. Similarly, for wind generation, the wind speed varies from morning, evening, noon time, night time. So therefore, we have to see the uncertainties and intermittency which are associated with the renewable sources. So we have to tackle those uncertainties. So, and again, you cannot predict what time it will be a full sunny day or what time it will be a fully windy environment. And for that also our storage should be ready to cope up our demand. So just you forget for a minute that we are not dependent on the grid. Our grid is not present. Our conventional grid power supply is absent. So we are completely dependent on the renewables and the storage, and the load has to be supplied 24/7 from the either renewables or the storage. It's quite challenging. So therefore, I'm saying who are working in the control field, their job is not at all less. They are also challenging task. So next, you have many people, they are working in the area of monitoring as well. Nowadays, we are keeping micro PMUs. Micro PMUs means, PMU means phasor measurement units. Micro why? Because let me tell you, smart grids is basically combination of microgrid. I'll tell you after this slide. Small grids we are making. Micro means small grid capacity based network. So those microgrids are basically in a particular area or some state. You have many microgrids. Then those small microgrids, they are interconnected with each other. And again, one state will interact with another state. And in another state, you have many more microgrids. Now, the researchers, they are saying this concept as cluster of microgrids. You can write even this. What is that? Cluster, CLUSTER, cluster of microgrids. So this cluster of microgrids may be AC or DC, maybe AC-DC hybrid, right? So this cluster of microgrids are the smallest unit of smart grid. So in that cluster of small microgrids, the micro PMUs are one of the monitoring device. So those monitoring devices are also important area. And one more device is coming of FDR, frequency disturbance recorder, if it is an AC microgrid. Also, we are developing smart meters. Also, we are developing one more FDR, that is the fault disturbance recorder. Fault. FDR stands for two things: frequency disturbance recorder and fault disturbance recorder. Okay. So these two devices are also already developed, and smart meter micro PMUs by many companies. They are now commercialized. Of course, micro PMU is not commercialized. Not manufactured in India. It is actually a product in US. PQ Lab. Exactly the laboratory name I could not recall. So you can just type the manufacturer for micro PMU. So now the point is this monitoring is one of the major research area. How to monitor the health of the smart grid or microgrid so that we can take proper action in proper time. So, and next, the stability issues, virtual inertia concept, and so many, and of course, not on more or less, you can say the communication technology, infrastructure, controller design. So, over top of it, I'll today talk to you some portion because time is a constant, the protection aspects. What kind of protection philosophy, difficulties we are going to face if these renewable sources, storage, electric vehicles are integrated to the existing grid or smart grid. So these are mm, some of the parts.
Hello, ma'am.
Now, so this kind of philosophy, as I said, this protection philosophy is one of the major aspects of the smart grid area. And let me tell you, this is one of the essential component. Why? Because I have gone through a survey. Around 5% of your cost of your, like, you are going to develop some generating station. So 5% of the cost of total generating station and all development, 5% should be dedicated for protection layers. Because I should not tell you why this protection is essential. I should not tell, all of you know it from the word itself. Suppose somebody is playing cricket, so the helmet, thigh pad, gloves, so everything, all our protective layers are required to save ourselves. Similarly, the protection layer is one of the important layer for whatever it may be. Even though how much your grid is smart doesn't matter, but protection layer is important every time. But unfortunately, the point here is to share with all of you the existing philosophy of the protection which are already present for our grid, that is not anymore suitable for the smart grid. This is obvious reason because now the topology has been changed, renewables are integrated, storages are present, electric vehicles are now going to be penetrated in a huge amount. By 2025 you will see that you are also driving one electric vehicle car. That should be the way. We should avoid this petrol diesel based engine cars. Of course, directly, uh, let me say, fully battery operated electric vehicles we may not go, but of course we may go for hybrid content. Hybrid means where your battery is lost, your battery is discharged. Of course, you can, I mean, depend on the IC engine where the petrol or diesel will come to picture. But of course, we can reduce 50% at least, not 100%, 50% at least we can avoid it. So there are so many concepts which are coming up, and it is realistic application. I am not saying that something is in research. No, whatever I am discussing with you all are already in operation and in application in real fit. So this kind of thought process, what I am just telling to you today, that it is realistic and we have to work hard on this front. Everyone has to work hard, then only we can beat it, those points what I'm talking to you. So this microgrid, as I said, this micro word itself is what? Suddenly I came from one journey to one layer to another layer, that is smart grid to microgrid. This micro means 10 to the power minus 6, isn't it? The micro means 10 to the power minus 6. The smart grid, if I'll tell any one of you what is our grid capacity, it is in the range of gigawatt. Giga means 10 to the power 9. So micro means 10 to minus 6. It will multiply with 10 to plus 9 with 10 to minus 6. So you'll get 10 to power 3 watt, means some kilowatt range of power handling capacity of the grid. So this kilowatt range of power handling capacity of the grid is one of the smallest grid handling power capacity. You can also write that a microgrid has a capacity of power handling up to 50 megawatt. Or sometimes also it is a new addition to amendment to the IEEE standards, that also it will be up to 100 gigawatt as well. Okay, so this 50 megawatt also has been extended up to 100 gigawatt, right? So this, and what is the voltage level range? The voltage level range will be within up to 33 kV. Maybe sometimes it starts from 230 kV, 230 volt, that is 440 volt line to line RMS. That is our lowest LVDC, we call LVDC or LVAC. LVDC means low voltage DC network or low voltage AC network, LVAC, right? So this low voltage starts from 230 volt line to neutral RMS or 440 volt line to line up to 33 kV. So this voltage level, more or less, microgrid is concentrated within 4.16 kV. That is 4.16 kV is not our standard voltage practice. It is mostly 11 kV. So more or less, it rotates within 11 kV in Indian context. And of course 440 volt, that is low voltage AC network. Now, so this small network has a good capacity of handling the power, and small packet of power or small energy parks we can develop near to our load centers, and the loads can interact easily with the sources. Understand what I'm trying to say? This microgrid has so many visions and reasons why this microgrid has been developed. Firstly, there are so many disadvantages are associated with the conventional grid. That was it was listed in my rest of the lectures I have outlined in my introduction to smart grid. Any one of you have opted it. So the major conventional demerit is the load centers and the generating stations are very far away from each other. So the load center has no control over the generating station, or the generating station has no direct control over the loads. So therefore, there is a mismatch, there is a communication gap between these two earlier. And secondly, that the power flow was unidirectional. Only the one load center can get supply from one generating station. That's all. And there was no, that communication from the load side to the generating station, or the generators cannot speak to the load centers. And there is, of course, the major drawback, there was no storage capability. The storage was not there earlier. One conceptual point here I want to tell. The grid, sometimes some students, they ask in my class also, whether the grid can store the energy or not. No, the grid cannot store the energy. Grid is actually the hub point, which will extend the power. That's all. It cannot store. It will just take the power and it will distribute. That's all. It cannot store. Therefore, the storage is very essential. So this small microgrid concept has come up with a solution that directly the load centers and the generating stations, they can talk to each other, they can share their thought process, whether the customers are satisfied with the supply voltage frequency or not, like or the sources are perfectly delivering the power to the load centers or not, or any uncertainty, any interruption comes in the supply, it will be removed, and it will be corrected quickly, and the power supply will be resumed quickly. And the customers will be happy, and their efficiency of the equipment will be very high, because there is no interruption of the power supply quality is good, and customers are mentally satisfied. That is important part, right? So of course, this microgrid concept is in the one phase of, you can say, development phase. uh, for example, I'll tell you, in IIT Roorkee, we have the power installed capacity is 8 megawatt. and our peak demand goes average, more or less average, if you ask me, 6 megawatt. Out of 6 megawatt, we have now 1.8 megawatt power we are getting rooftop mounted solar energy system. It's a good number, isn't it? We are getting 2 megawatt out of 6 megawatt. It's a good number. And this solar rooftop mounted solar energy, we have invested before, if I'm not wrong, in 2013, around 30 crores. So all the departments, centers, residences, hostels, areas, and buildings, our administrative buildings, everywhere we have the rooftop mounted solars. But honestly speaking, we don't have any storage till date. We are trying to put one storage. We have put, ABB has mobilized, and it has been installed, and it will be operative soon. So we are losing so much of energy from the solar energy panel. It is not optimized. It is not utilized in an optimal manner. If you could have optimized it, it will be maybe 50% of the power of this campus will be fulfilled by solar itself. So this is how slowly we have to develop. In India, we are not in a phase of in a very pace manner, I cannot say, optimized way. We are not handling the smart grid concept, but still I hope by next 20-30 years it will be fully implemented. Right. So this is one of the AC microgrid. I have not written here AC. It is not DC. It is AC microgrid. Okay. And you can see my picture. Here is the main grid. This main grid is connected to the. This is the different types of AC microgrids are there, depending on its structure. I mean layout of the microgrid. So it is actually a maze type AC microgrid. Maze. It is not radial. It is a maze type microgrid. Okay. Now here one main grid is present, and here is a main connecting transformer. What do you mean by main grid? The main grid is that grid which supplies power to the microgrid, and that power supply may be NTPC based power supply, that is coal based power supply, or hydro. Our main hydro stations we have in India, that power supply may be. That is actually the main grid. Conventional grid we call it sometimes, or main grid we call it. So this is the transformer, main connecting transformer, and this after that we have a main circuit breaker, and this portion is the main grid. And this is the utility side we call utility, main utility. And this transformer and the circuit breaker, everything is owned to the utility side. And the point where this main grid is connected, we call it as point of common coupling, PCC. Okay, and then rest of the things network, as you could see, that is your AC microgrid. Fine. Now here you have fuel cell, you have battery storage, you have micro turbine, you have biomass generation, PVRA, DFIG, diesel generators. The diesel generator is for your backup supply. DFIG stands for double fed induction generator. That is actually wind generating station. You have many types of machines. It is a different area. PV system, biomass. So micro hydro means small hydro power plants, micro turbines as well. So this sort of layout is known as microgrid. All are interconnected. You have also nodes, you have also storage. So why do you think, if you'll tell me the protection philosophy, the challenge, the vision, what could be our vision to protect any sort of network of the AC microgrid, DC microgrid, a hybrid AC DC microgrid, whatever it may be? So this is a very big front of research area now. Not only research, in industry people also, they are trying to give best solution. if you have solar interconnected, so what will be your relay setting, what will be your philosophy of the protection philosophy. So those kind of analysis they are just trying to do. Okay, now I'll tell you few of the issues. If you are interested, maybe 5 minutes break, ma'am, we can take, if you'll allow, and then I can start the second half of my
Okay,
presentation.
okay, ma'am.
Is it fine, or shall I continue? If you'll tell me, I can also continue. What is my time? Time.
So, ma'am, your generally up to 12 p.m. Lecture session is there, and for 30 minutes for question and answer.
How much for question answer?
30 minutes, sorry. Uh,
Okay, okay, fine. That's very nice. I request all the participants, if you'll ask me more questions, I'll be very happy, and I'll very happily I can answer. If some questions I could not answer, even you can mail me, and afterwards also I can answer to you. Okay. So, ma'am, can we take for 5 minutes break?
yes, yes. We will continue within 5 minutes.
So next we will again continue up to 12:30. Fine. Up to 12 I'll take my lecture, then
Ha.
12 onwards I'll take the questions. Fine. Yeah.
આપણે લેવો ને બીજા હા ચંપો કોલેજ માટે રાખો
Hello, sir. Hello, ma'am.
Yeah,
Yes.
ma'am.
So yeah. So we'll start now. So this. So we have stopped here, like protection issues in microgrid. What are the kind of issues we are going to face? The first issue will be the dynamics in level of fault currents, and second one is the bidirectional fault current. Third one is the fault stripping and blinding of protection. So this four set of issues I'll discuss one by one. So the first one is the, as the name suggests, dynamics in fault currents. Let us say, what is the meaning of dynamics? So when this, let me tell you one more point here in the protection of the AC microgrid or DC microgrid or hybrid, you can say. So there, the fault is one of the major factor, and the fault, all of you, I think you know, that is actually one uh, fault is very inevitable in nature. Inevitable means anytime the fault can come to the network. Like natural faults means one line which is touching to the tree, or some sort of two lines are sorted, and in case of cables, if one cable is punctured, in the upper layer of the insulation is failed, then the conductor may touch to the ground. So, or maybe two conductors may touch to each other. So those kind of faults may occur inside the network. And also you may, I'll mostly talk about the line faults, not the bus fault or some transfer faults or some device fault. There are so many other faults also, but I am just concentrating here on the line faults. So this line faults, when it is incepted in any of the feeder, so the source which are present inside AC microgrid, so this they will deliver, they will try to push the current to the fault point, because the fault point is the lowest voltage level. hmm? Lowest voltage level is at the fault point the voltage dips, right? The voltage dips. So it is a very common thing, or it's a basic principle in electrical engineering. The current flows from higher voltage level to the lower voltage level. So from this AC main grid and the DERs which are present in the network, so they will try to supply the fault current to the fault point. So the dynamics means the changes in magnitude of the fault. Due to the integration of renewables, I named there here it is DER, distributed energy resources. This is the IEEE standard name, or sometimes we call it as DGs, distributed generators. So this renewable sources which are connected, here the two renewables are connected, DER1 and DER2, and these are the loads, load 1, load 2, and this is the main grid. So when this fault is created in this feeder, which is originated from the main grid through this PCC, so one current which is coming from the main grid side, that is IGF, capital GF, and these two are the fault current which are contributed by the DER1 and DER2. This is IGF1 and IGF2. So now finally this fault current is the addition of the fault current that is contributed by the grid, by the all the renewable sources which are present in the microgrid, in the grid. So this therefore, let us say your for example, you think that these renewable sources are not present. Okay, so in that case what will happen? The current contribution by these two renewable sources will be zero. Only the main grid has to supply the current. Okay. Similarly, and in case of like when these renewables are connected, the fault current magnitude will increase. Similarly, this is known as this operation of the main, microgrid is called as grid connected operation of the AC grid. Now this this side operation of the AC grid is called as islanded operation, where the main grid is absent, only the renewables and loads are present. This mode of operation is called as islanded mode of operation. So islanded means the main, suppose there is some fault in the main grid side, and therefore the main grid circuit breaker is opened, and otherwise that fault, because that fault will be more severe, because this renewable sources which are present, they may supply the current to this grid side fault. Okay, so therefore this main grid circuit breaker will be opened, and the main grid will be disconnected from the rest of the network. This mode of operation of the AC microgrid is called as, it is known as islanded operation. Now in this islanded operation, if there is suppose some fault in the main feeder, now the main grid is will stop supplying because it is off. Only the two renewables which are present in the AC microgrid, they will try to supply fault current. So as a result, the fault current will reduce. So what is the take home, the idea we got from here? That if the AC microgrid is operating in grid connected mode, then the fault current magnitude will be higher, and if it is operating in an islanded mode, then the fault current magnitude will be reduced. This is the conclusion from this. So therefore the dynamics means the change in fault current magnitude changes time to time. So that means a fixed setting of the relay you cannot maintain. Earlier what we used to do, we mention a conventional relays, we maintain a single setting, fixed static mode of operation. But you know, from this a small example I demonstrated in front of you, that if your renewables only present, I have not kept any battery or electric vehicle over here. So that means every time our fault current magnitude and angle, as well as they are modulated time to time. I mean they change time to time. So to accommodate this changed scenario, dynamics scenario of the fault current behavior, so we have to also make the relay setting as dynamic. That is called as adaptive. So then we have one more issue, bidirectional fault current. As let me tell to all of you that earlier our network was unidirectional. Unidirectional means the power flow was from the generating station to the load side, right? Because there was only one substation, and from the substation we used to supply power to the different load centers. So in that case, what happened? What will happen? The power will flow from the load, I mean the generating station, to the load centers. In between there will be no power supply. Or load centers also, they cannot supply the power back to the grid. Okay? Please mute your mic. Yeah, thank you. So this bidirectional fault current means, now due to the integration of renewables to the existing network, then if there is some fault, then the power flow may be from any side, isn't it? The power flow, because the current is going to be contributed by the renewable sources as well, right? So therefore, for example, I have kept one example in front of you, that the green one, let us say one fault position, red one is one fault position, and this is my observation point. Here my cursor, you can see, this is my relay R1 observation point. For my fault F1, this grid will supply a fault current red dotted line, and the renewable source will also supply a fault current dotted line. So it will see this relay location, it will see a fault current from left to right or upstream to downstream. Upstream means Generally, the grid side is denoted as the upstream side, and the downstream means that is the load side mostly, and of course renewable sources side also. That's a downstream side. So if any fault occurs in this bus bar of the PCC, let us say F2, so again the renewables will also supply one fault current to here, and but it is in reverse direction. So this relay R1 will see two currents for different fault positions in left upstream to downstream, and then downstream to upstream. This is known as bidirectional off, and it creates problem to the many relays, digital relays, where it creates problem. Now you have one more issue in this context, AC microgrid mostly, that is known as the fault stripping, and it is very well known from the name itself. That means a healthy feeder is going to be fault stripped, and however the faulty feeder will be tripped, and healthy feeder will also be loose to the healthy feeders, and that is known as fault stripping. How it does, how it happens? Let us say I have taken this example here. This is actually our main grid. This is main circuit breaker, and this is a PCC point, and these two are the feeders, feeder 1, feeder 2. Okay, in feeder 1 we have one renewable source which is connected. Let us say one fault is incepted in feeder 2. Okay, so to this feeder point, feeder 2, the fault current will be contributed by this DR as well as for the grid side, both the sides, isn't it? Because these two are the sources present in this circuit. Now, this relay R2 is going to be, it is going to trip this feeder 2, no doubt, because the feeder 2 is the faulty feeder. But however, feeder 1 is also going to be tripped, because R1 also will see some sort of high amount of current. Okay, so therefore feeder 1 has no fault, but still it is going to be tripped, and this concept is known as fault stripping. Okay, so this sort of issues are very common in due to the integration of renewables, batteries, or some electric vehicles to the our existing network. The last issue is the blinding protection. That in case of blinding, as the word itself names as blind, means there is a fault, but the relay is unable to detect the fault, and that concept is known as blinding of protection. So this why it happens? For that I have taken this picture. Okay, this is the main grid, this is the PCC, and here is the relay location, and this is one feeder which is originated from this PCC bus, and this is actually the point where the renewable source is integrated to the feeder. Okay, and there is a fault in front of this DER. Fine. Now when this fault is incepted in front of this DER, what will happen? What will happen? Both the main grid and the DER both will contribute the fault current point, isn't it? So that means in this process, let us say the DER not present, but only the grid supplies the current. So that means the relay will see more current. But as now the DER is also contributing the fault current, the current contribution by the main grid will be reduced. So as a result, the relay, this current contribution from the grid will be reduced, and the relay will see less amount of current. And sometimes it may happen that this current seen by the relay, the fault current seen by the relay, it may fall below the setting of the relay current. So therefore, even though there is a fault, the relay has to take some decision, but it could not. It is known as the blinding property. Okay, due to the presence of this DR contribution. So that means we have to change the relay setting. With a fixed set mode of setting, we may not take the proper decision, or we may not be able to clear the fault, or we may not be able to clear the faulty section. These are the some of the issues, major issues I have discussed with all of you. There are so many other issues are also there. So I think one more point I just want to add here, one issue, that is the eye landing detection, and then we'll find out. Now you see this, for this picture I'll keep to the end of my talk, and I'll tell you what are the issues I have discussed. which relay will see what kind of problem. So in our group, we have in IIT Roorkee, we have a very group of students, PhD, MTech, and BTechs also to some extent, and other faculty members also. We work together, and we have good group of smart grid protection, control, monitoring. Those actually stuff we are doing. And one of my student, he has developed one adaptive protection scheme for islanding detection. So islanding is what? This is also one of the protection issue of the AC microgrid. What is that? In AC microgrid, we have the main grid and the renewables. When this fault will occur in the grid side, the main breaker has to be opened and the rest of the network will be disconnected from the main grid. Now this adaptive center, the main microgrid control center, he has developed, and these are some of the relays. Please mute your mic. Yeah, so now when there is a fault on the main grid side, so rest of this AC microgrid there, it is going to be disconnected. But the problem is this islanding means microgrid is going to be disconnected from the main grid. What will the subsequent results, consequences? What will happen due to the power mismatch within this islanded microgrid? The power quality issues will come. Personal theft may come because some people who are working in this substation, they do not know that the main grid is off and still they are working. They may get shocked, and also there are so many other protection issues will come to picture. So it is very essential to detect such kind of mode of operation of the microgrid, and we have many techniques we have developed, like passive islanding detection technique, active islanding detection technique, hybrid islanding detection technique. Hybrid means both passive and active techniques are merged together, and also communication based techniques. So in this paper, one of the student, he has developed one passive technique. So what we did here, that we have taken the data. We have monitored the voltage and current at the DG terminal, renewable source terminal, and we have estimated the phases of the voltage and current using least error square based technique. Then we have calculated the negative sequence of the voltage and current, and we have calculated the superimposed impedance, that is J2 post minus J2 pre. This is known as superimposed impedance. And then we took the rate of change of the impedance, superimposed impedance. Then we got some value. If it is crossing some threshold, then we declare that the AC microgrid is disconnected from the main grid. And if it is below certain threshold, then we declare it that it is not disconnected from the main grid. So the question now is, what is the need of this all this requirement? We should know the status of the AC microgrid, whether it is connected to the grid or it is disconnected from the main grid. What is the requirement? The requirement is, if we have to know this, because that quickly it will not shut down or de-energize the DGs. Otherwise, there will be power mismatch and there will be frequency deviation, voltage deviation, power quality issues will come, some loads will be disturbed. So therefore, we have to de-energize the renewable sources. But let me tell you to all of you that very recently, this kind of islanding is known as unintentional islanding, because we are not ready for this, but it had happened. Okay, so this is known as unintentional. But now the company, the IEEE standards, they are telling that they are discouraging for this sort of disconnection of the renewables, because we are losing our money and we are losing the power generation. So therefore we are going for intentional islanding scenario. Intentional means if there is some fault in the upstream side, some areas can you separate with some loads and some renewables, and they will just operate in a stable manner. Small islands will prepare, and there are small areas where few generation, few loads, they will match together and they will operate separately. So this is also one of the very merging area coming up. And finally, when the scenario will be better, then again the small islands will reconnect, rejoin the main network. So this is how the third process regarding this. This is the system, one microgrid we have developed through RSCAR environment of that DS real-time digital simulator package, and we have verified our technology. And one more here things I want to share with all of you, that whenever you do some simulation, it should be verified with some hardware setup. And fortunately, in IIT we have one device called as RTDS Real-Time Digital Simulator, and we have the space over here. And this whole microgrid runs in the RTDS, and we took the voltage current signal to the DSpace, and there the algorithm we execute. And again, we come back with a decision to the to open the or de-energize the renewables or not. That decision will be taken. So this is known as HIL, stands for hardware in loop test. Why it is essential? Because when you are proposing some technology, some technique, that should be also verified whether it is possible in a real environment or not. So that is what this RTDS provides us. Okay. So that much from my side, and thank you so much. These are some of the harder results. I think I'll end here. Thank you for your patience hearing. Any questions? I'll be very happy to chat with you, interact with you. Yeah.
Participants can unmute and ask questions.
Some participant, he has written Rama Prasanna Dalai. It is, the question is, all the protection issues can be observed for AC or DC microgrid or both? Yes. See, actually, the protection philosophy for AC are different, and the protection philosophy for DC are different. All the philosophies for AC are different, and for DC also different, because DC has its own behavior. DC has no zero crossing, it has no frequency part, no reactive power part. So it has a different behavior than the AC circuit. So, but everywhere the protection issues are there, no doubt. But their behavior, their protection challenges are different, and of course, depending on their behavior, the protection philosophies are developed. Okay. So, any further question, please?
Hello, am I audible, madam?
Yes, you're audible. Please.
Madam, you have discussed regarding a microgrid fault protection issues. Can you just tell me about a transmission line while DG is penetrated?
Pardon? Can you repeat again the question?
You have discussed regarding a microgrid protection issue when DG is penetrated in the system,
Yeah.
right?
Right.
So when the penetration is more, there are the issues in the transmission line also, right?
Exactly. See, yes. Complete your question.
So the same kind of issue can have in a transmission line, madam?
Yes, actually, as I said, the microgrid I am talking